All right, let's get ready for our upcoming test on quadratics. Starting right off the bat here with our graphing portion. Up on this top part, you'll notice there is some guidance, and the same guidance that you see on this review will be the same guidance that you see on our test itself when we get there. So here on number 1, notice that it mentions that we're going to want to find the vertex right away. Now there's a little formula for that. Notice, not here. You need to know this one. To find the x value of my vertex, we use negative b over 2a. So again, my a value in this case would be 1. My b value would be negative 2. And I'd plug those in. But again, be careful. The opposite of b, the opposite of negative 2 is positive 2. Over 2 times 1, which would also be 2. So 2 divided by 2 is 1. And that's the x value of my vertex. Now, to find y, I can do one of two things. I can either stick the 1 back in for both of those x's, which in this case, that's kind of simple. So let's just go that route. 1 squared is 1. 2 times 1 is 2. So 1 minus 2 is negative 1. Minus 2 is negative 3. So my vertex is at 1, negative 3. Now let's say you weren't quite sure after you did that. You're like, maybe I messed something up. Well, we're going to find out in a minute if things went well or not. So I go ahead, I type my expression in, and if I look at my chart and I get my x value of 1 in the middle, do I see symmetry? And if I do, I know I did it right. And I also can double check my y value. So good, I'm doing everything right so far. So I can go ahead and plot that point at 1, negative 3. And once I do that, now I could go ahead and either use my chart to be able to get my other points in, or I could use my pattern. Either one of those would work. So I can go ahead, get those connected, and I'm good there. Okay, my axis of symmetry, again, reminder, it's x equals and the x value of your vertex. You have to have the x equals, otherwise it is a number, not a line. Just saying. Okay, and that'd do it for number 1. Now for number 2, we have a little different of a form. The easier form, actually, thank goodness. Okay, vertex form. Let me scooch this into the screen a little better. I should be able to get my vertex directly from here, because again, vertex form traditionally, okay, looks like this. So why do I need that? Why is that important? How could that help me? Well, remember, it reminds me it's the opposite of this value, and then I keep whatever values out here. Helps me not mess this up. So negative 2, negative 1. And again, at this point, you have choices. You can do the pattern. We've talked about that before. I can go up 1 and over 1. Up 3 and over 1 each way to make my points. Or if you happen to not remember that, sometimes quizzes and tests can do that for it. Our brains kind of go, and we panic, so we like to have a backup plan. Get my chart. I double check here. I see the symmetry, and I see negative 2, negative 1. Hot dang. And then I check the other points. Negative 3, 0, and negative 1, 0. There they are. And negative 4, 3, and 0, 3. Okay, so pattern, chart, find success either way. So now for my last 2 bits of info. I don't need the calculator for this, at least not at the start. So we give you the formulas for focus and directrix, okay? Won't have to worry about having any type of cheat sheet or anything. They're right there for you. But the question is, what's my a value? My a value is whatever number's in front of the parentheses. In this case, since there isn't one, we assume that it's 1. We also know, with our form from before, that my h and k are my vertex values. So here's h, here's k. So h, now for the other part, I'm going to do a little side work here. So I'm going to scooch this a little more over. It's k plus 1 over 4a. Okay, that's what this value is going to be. And again, simplify this stuff. 4 times 1 is 4. So it's negative 1 plus 1/4. Now, if that's not something you're comfortable dealing with, you know our old backup plan. Negative 1 plus 1/4. Okay, I don't even care if you use the decimal here instead of the fraction. Doesn't bother me a bit. So negative 0.75. Perfectly content with that. When I get to the Directrix, okay, it's k, negative 1, minus 1 over 4a. Or in other words, it's going to be negative 1 minus 1/4. So again, negative 1 minus 1/4. Well, not 145. No, that'd be bad. And I'm set. Again, it's following that in and letting the calculator do the work for me. Shouldn't be anything that's going to be too incredibly rough for me at all. So that'd take care of that part. And we come, oh, here comes our nemesis. Even trying to help some of you out this time. Solve by factoring. Solve. Get the x values. Okay? The blanks and parentheses are all I'm going to be here for you. So remember, multiply to get the number in the middle. Add to get the number in, multiply to get the number in the end. Add to get the number in the middle. I'll spit that out, right? So, multiplies to get a positive. Tells me you're going to be both positive or both negative, but the add number's negative, so I know this. So what's that tell me? It tells me I need two numbers that multiply to 18 that add up to 9. What would those be? 6 and 3. And again, to get the x equals part, I got to set these equal to 0 and get my solutions. Okay, and unlike the radical ones we'll be doing a little bit later, we don't have to worry about, oh, those answers work, they do. Okay, get my solutions. Now the next one, again, we're looking for patterns. Ooh, what's special about 4 and 49? They're both perfect squares. Okay, so what do I square to get each of my terms? Well, 3 squared is 9, and x squared is x squared. 7 squared is 49. I have all the values I need now to put in my parentheses. 3x, 3x, 7, 7. And since I'm multiplying to get a negative, one of each. Okay, set those guys equal to 0. Minus my 7 over on the first one, add my 7 over on the second, and these I do like putting as fractions instead of decimals, because I'm not graphing or doing anything like that where I'm going to need to know those exact values, so I think this is the more proper way to go. Now, on our last one, now there's going to be options here. I know how much some of you love options. This last one, the easy way would be if you recognize the first and last terms are both perfect squares. If you do, you notice you'd square 4 to get 16. You'd square 5 to get 25. And since it's a plus in the middle, I'd just do it like this. And since they're the same, I don't have to do this twice. You're like, okay, but Harty, you know, me and patterns don't tend to get along. You know, is there another way just in case I don't remember the squared thing? There is. It's not quite as much fun, but let me show you. If that doesn't work for you, my backup plan is to slide and divide. So if I go that route, multiply to 400 and add to 40. Might take a while. Okay, but I'm going to do the Cliff Notes version here, because normally you'd bust out the calculator and you'd start dividing numbers into 400 until you found 2 that when you played with them, they got to the answer. Now here, since we don't want to take up a bunch of time here, especially if some of you know the answer already, I mean, again, you might take 400 and go, oh no, 2. Well, are those going to add up to 40? No, I'm not even close. So maybe I start taking bigger numbers. Ooh, 10 and 40 or 50. I got to be getting close. Does 15 even go in? No. I'm close. I'm close. Ooh, 20 and 20. 20 and 20 add up to 40 and multiply to 200. But don't forget, slide and divide. And now do you kind of see why those perfect squares, knowing them is helpful? You notice how long this is taking me to get done when I could have been done like a couple minutes ago? Be careful, because some of you are going to do this and you're going to do a great job up to, whoa, you're going to do a great job up to here. Then you're going to do something boneheaded. You're going to punch in 20 divided by 16. You're going to notice that it doesn't go in nice, and you're going to just put 16 back in front. That doesn't work. Make sure, math, enter, that you're in your most simplified form, because then when you spin it back to the front, you end up with the same factored form that we did when we did it on our own over here. 4x plus 5, 4x plus 5, and you get the same answer. But again, there's benefits to knowing things like your perfect squares to make this easier. And no, it's not time to go. I'm just working between classes. So, options, options, options. Solve by using square roots. Don't forget the plus minus. Reduce all the radicals. Shoot, can't tell you much more than that. So, get my square root in there. So squared and square root are opposites. Don't forget my plus minus, okay. Can the 24 break down? Okay, if need be, bust out the green sheet. 4 and 6, because again, one of the two numbers has to be a perfect square, otherwise this is kind of useless. Like if I did 2 and 12, 3 and 8, and it doesn't help me much. 2 square root of 6. That's what I'm looking for right there. Boom. So as I'm doing these, again, we want to try and isolate our x squared term. I've always got to try and get that as isolated as I can before I do the square root. Like for instance, in the last quiz, some of you got to this step and then you square root it. That doesn't help me because square root of 2 is kind of yucky to deal with. I want to divide that out of there first. Once that x squared is alone, nothing multiplying by it, nothing adding by it, anything like that. Now I'm ready for the square root. I'm ready to go to my plus minus. Right after, I make sure it doesn't break down. Ooh, I think I'm giving you a hint. It does. The one that breaks down, do it. The one that doesn't, well, leave it alone. Still acting irrationally in radical jail. And then our arch nemesis from the last quiz. Get that 3 out of there first. Don't distribute it. Okay, that's not sensible in this case. Okay, here, don't distribute the squared. Again, not sensible, and you won't get it right anyway because you'd have to FOIL it out. Do my opposite. This is the one time I can do square root before the last step. 10. Yes, I actually gave you one that doesn't break down. It's a miracle. So what would my last step be on this one? Yeah. I'm going to plus the 3 over, not under the radical. Just put it in front because that's the only place for it. Okay? So again, I really need to pay attention to detail. It's not that there's anything terrible in any of these. It's just we've got to make sure that we're taking the time to do it right. Okay, simplify each expression completely. Write it in standard form. A plus b, I. Oh, time to take i's out. When do I take i's out? Oh, try to take square root of a negative. Take an I out. Take the I out. What's the square root of 100? put it with your I, you're good. Not square root of 10. Square root of 100 is 10. Radical goes away when we're good on perfect behavior. I can't stress this enough. On 10 and 11, we're not foiling. Okay? Yes, I have to distribute my negative. But that's the only quote-unquote multiplying I'm going to be doing. Okay, again, not time to go yet. Just saying. Find the terms that are alike. Find my constant terms. Combine the other like terms. Okay? Combining like terms. Don't multiply. Okay? Same thing on 11. Distribute what's on the outside of the parentheses for each piece. But then just combine the like terms. Don't make life complicated, please. Okay? And as we keep going with this, mercy, there's a lot of bells around here. Now I actually have to multiply this out. And again, my favorite means of doing this is by using a box, because it forces me to make sure I multiply each term in here. Again, we're multiplying to fill the box. 2 times 6 is 12. 2 times 8, 16i. Negative 7 times 6 is negative 42i. And negative times positive is negative 56i squared. But remember, I squared is negative 1. So this is really negative 56 times negative 1, which is positive 56. So now that I've got that all simplified in there, I'm just going to combine my like terms. 12 and 56 is 68. 16i minus 42i is minus 26i, and we're done. But again, that's the only time I'm multiplying or foiling out, is when there's no symbol in the middle. Otherwise, don't do that or it won't be right. Okay, last place where we can have an issue. Well, at least for this section. Okay, 13. We're going to multiply by the complex conjugate. What the heck does that mean? Well, here's what we got working. I got to change the sign of my I term when I'm multiplying through. So if I had 2 minus 3, I'd be using 2 plus here. So I work this through. Up top, I'm just going to distribute. Okay, that's pretty straightforward. Now down below, guess what we get to do? Foil it out. Box it out. And it doesn't matter which way we put them on the side of the box. If you put the plus 1 on top and the minus 1 on the side, that's okay. And again, I'm going to multiply the sides together. And my reason, again, for doing this is going to be, I don't want i's in the denominator. That's not allowed. You're like, Harty, I still see i's. Well, just wait. I squared is negative 1. Negative 9 times negative 1 is positive 9. 4 times 9 is 13. 6i minus 6i cancels. No i's left. Woo! Okay, so say goodbye to I. No more of that for now. Okay. So next, solve by taking the square root. All right. You're like, we've already done this. Well, I've got to do it again. Isolate my x squared term, Sometimes it may only take one step. Other times it may take a second. But until that x squared is alone, don't do the square root yet. Even if that was a perfect square, don't do it. Not until we're isolated. Once we're isolated, once it's just x squared left, now I can take the square root. Remember, plus minus, oh, negative under the radical, he's back. Take an eye out. Okay, so this is really I times the square root of 9, which would be 3i. If you put I 3, I'm not going to yell. 3i is a little more proper, but that's okay. So again, that gets us situated with our I. Okay, solve by completing the square. Oh, I'm feeling a song. No, I'm not. Okay, so completing the square. Get your x terms on a side by themselves. The x side, remember, we're going to need a blank. And on the side where I moved the 8 to, we're going to need a blank. What goes in the blank? Okay, again, remember back to the crazy Harty song. B divided by 2, the number in front of x, divided by 2, and square it. That goes in the blanks. And that number goes in there and is helpful to us because now when I go from a perfect square trinomial to the square of a binomial, what number is going to go in with the x? Yeah, that positive 3 that I see here, my b divided by 2. And now it just looks like the square root problems. Again, I can't distribute the squared. I don't want to FOIL it out. I want to work on getting to my x. Scooch over this way a little bit because we're going to have a room issue. 17 doesn't break down. That'll happen sometimes. But I still need to finish this. X isn't alone yet. So I'm going to minus the 3 over. And I'm set. But again, I got to remember the b divided by 2 and square it part. It's not a real hard thing to remember. Okay? Kind of a short little thing again. And so now application, which I'd warned was coming. Hannah was asked to rewrite the standard form of a quadratic equation in vertex form by completing the square. She did not do it correctly. Explain her mistake, then find the correct answer. Okay? So I look and I'm like, now I remember this is vertex form, so that part looks good. So let's see what she did. So she sectioned off her x terms. Okay, that's a good idea. So let's see. B divided by 2. B divided by 2 and square. Oh, what's 4 squared? Yeah. So what do you think she did? How do you think she came up with 8 instead of 16? That's kind of what I might be thinking too. I think she might have thought this is 4 times 2 instead of 4 squared. So she did 4 times 2 instead of 4 squared because she got 8 instead of 16. So let's fix it for her. So where she's got the 8 and the 8, we know that should be 16. And then we know this is a perfect square trinomial that we can simplify to its binomial form. Again, by taking my b divided by 2 number, or I could factor this. Almost forgot my equals. And again, to get to vertex form, y's got to be alone. It's like anything else. Once you've given it a go a few times, it's not too bad at all to deal with. But again, the only way I get better is by playing around with it, especially when you're completing the square, you're using it in vertex form. I mean, there's a lot of ways this can be done. Speaking of, write the circle in standard form. Okay. Now again, we talked about this before. I'm going to take my x's. I'm going to put those together with a blank. I'm going to put my y's together in parentheses, also with a blank. And then since whatever I do to one side, I have to do to the other, I also have to add those same two blanks on the right side. Okay, and if that 23 would have been on the left, I'd have needed to move it as well. But you know the drill after this. I got to do my b divided by 2. And I got to square it. I got to do my b divided by 2. Don't forget the negative. And square it, which will come out positive because I used parentheses. And now the last step to get it into its circle form. X, you know it, positive 2. Y, keep using what's there. All the clues are there for you. And then 36. There is my standard form of a circle. And now to get my center and radius, I just steal them straight from the problem. But remember, it's opposite of h, opposite of k, and my radius is just the square root of my answer. Not bad, not bad at all. Okay. Now 18, a lot of you will look at this, say, ooh, story problem, ooh, words I don't know, skip it. Notice what's bolded and underlined. Okay? Talks about impedance and ohms, and add the complex numbers. All you are doing is that. Like for real. For real. Combine like terms. And there's your impedance. You didn't even know you knew how to find impedance of circuits. There it is. Okay, that's it. Don't skip it just because it's a word problem. Okay, there's no need. All right, more application problems. Gracious. So the area of the rectangle shown is 51 square meters. Find the value of x in the dimensions. Use your calculator, solve up using an algebraic method. We've done just about all of ours algebraically, and there's not a problem with that, because that's the way I'm going to keep doing it. So area is length times width. So area, they told me is 51, is length times, 2x plus 11. Now, no matter if I would do this with factoring or the quadratic formula, those are my best options, I'd have to distribute this out. Don't forget the x goes to both terms. And I also need to move the 51 to the other side. I need to subtract it. Now, I'm going to bet at this point, it won't be all of you, but it's probably going to be a majority, aren't going to like the idea of having to factor this because it's slide and divide and it's bigger numbers. If you don't want to go that route, not a problem. We use the quadratic formula. Okay? And if you haven't noticed, I'm just peeking around here, seeing where our quadratic formula is. Oh, okay. Always look around on these quizzes and tests and things. If you don't remember the quadratic formula, it's right there. You may have to go look for it, but it's there. So back to our regularly scheduled programming. Okay, opposite of b, plus or minus, square root of b squared minus 4ac all over 2a. Again, I would not expect you to do this in your head. Let's go calculatoring. So let's see here. 11 squared minus 4 times 2 times negative 51. And I want the square root of that. Let's see if it comes out nice. Oh, it does. Okay. So negative 11 plus or minus 23 over 4. So I take care of each of those. So I do negative 11 plus 23 divided by 4. You're like, Harty, why didn't you just type it all in at once? Okay, let me show you something. Whoa, how'd that happen? Because if I'm going to do it all at once, and this is why I usually don't, I've got to make sure I use parentheses for the numerator, or my answer is not going to come out right. So if you want to do it that way for the second one, okay. Do both of those answers make sense? Again, we're looking for the sides of a rectangle. Not really, okay? Negative doesn't make sense. So my x value is 3. And then the dimensions are just plugging that 3 in for the x's. So 3 there. And then 2 times 3 is 6, plus 11 is 17. And 3 times 17 is 51. I'm good. Okay, I've got that instant check in there. Now we start getting into some calculator stuff. Okay, Maya is going to shoot an arrow upward. The height of the arrow after t seconds is given by the equation negative 16t squared plus 90t plus 7. What was the initial velocity of the arrow? No math to do here. It's the number in front of t. It's the number in the middle. That's it. All right. So then, when was the maximum height reached? This is just my opinion. Again, we're still not ready to go. I think life is going to be easiest by just going ahead and typing this in the calculator. Now, I could use, and I will mention this in a bit, I have some options. I could use the quadratic formula for this if I wanted to. I'm not going to do that on here for amount of time so we can get everything in here, but that would work. Because here, if I go ahead and I graph this, like, whoa, Harty, I can't see the max. Okay. Here's what we're going to do. We look at our chart, and I'm looking at the y values. When do they quit going up? Like right here, 133. Okay, so for my window, which would normally look like this, since 130 was the biggest y, I'm going to go bigger than that. I'm going to go to 150, let's say. Okay, there, now I can see it. Second, trace. I'm looking for the max. And remember, we used our left and right arrows to get up to the top as close as we can. And then we clicked 1, 2, 3 times to the left. We hit enter, got that locked in. We went 3 to the right to get back to the top. 1, 2, 3 more to get to the right. Locked it in and guessed. And so what this told me was that we were about 133.6 feet at about 2.81 seconds. Okay, I can't just use the table on this and go closest. I need to get an answer. And again, I could use the quadratic formula to get the x value. And then to get y, I would just plug this back in where the t's are at. So if you don't want to play with the calculator, that's your option. And you could do it that way. But wow, this is a lot faster. Okay? Just something to ponder. Now, we're going to do some applications with this down below. Okay, complete the table to show the height at the given time. So again, the calculator is going to make my life simple. Second graph. Again, my time is x. My height is y. So 2, we're at 123. 4 is at 111. 6 is negative 29. It says find the average rate of change in height from 2 to 4. Use change in height over change in time. It's slope, okay? Change in height from 2 to 4, okay? So 123 minus 111. And And then we'd have 2 minus 4. And I'd go ahead and I'd subtract. Find out it's going down about negative 6 feet per second. It's going downward 6 feet per second. Not a hard thing, just an application. And when did the arrow land on the ground? Again, that would be my h of t being 0. So I go back. To me, again, it's easier to do this on the calculator. I'm going to do second trace, because that's where everything is, like second trace. I want the 0. And we talked before about what I want to do here. What I'm actually doing, okay, is I'm trapping this point in. So my first point, I want to be a positive y value. Okay, y is positive right now. I'm going to go ahead and hit enter. Then I'm going to keep hitting right until my y gets negative. Because that's going to mean I got a positive and a negative, and my answer is going to be in the middle. So I hit enter, and I hit it one more time for the guess. And I find out it's going to take about 5.70 seconds for that sucker to hit the ground. So, again, I do need to play with some button presses. And if you come and ask me during the test, I'm probably just going to say, you need to do second trace menu, but I'm not going to tell you step by step everything to do. Because this is like the 5th or 6th time we've been doing this, and if we haven't practiced, So, to the back. Michael throws a rock from the treehouse. They give us an equation. Use the quadratic formula to identify when the rock hits the ground. Okay? Use the quadratic formula. It's right there. Use that. Okay. Opposite of b. Square root. B squared minus 4ac all over 2a. Now that is a pile right there of stuff. So let's see here. 36 squared minus 4 times negative 16 times 15. 2256. Square root 2256. Now, here's the one time, again, when we're in an application, it's okay to go to a decimal. So for instance here, I've got negative 36 plus or minus 47.50, we'll call it, all over negative 32. So I'm going to get my two answers. Because again, I've learned negative 36 plus 47.50 parentheses divided by negative 32. So one of my answers, I get negative 0.36, that's the nearest hundredth. Then I do it one more time, minus 47.0 divided by negative 32. And I get 2.61, okay? Those are my two x values. Do they both make sense? Because again, we're talking about the time it takes for this rock to hit the ground. Do they both work? Not this time, okay? Negative time doesn't make sense. Hit the ground before I ever dropped it? Yeah, probably not. So I've only got one answer that really works. Okay. So we talked a little bit too. And I don't even care if you do this verbally. Okay. Draw a sketch of a quadratic equation that has one real solution, which means it has one x-intercept, which means when I draw it, it only hits the x-axis in one place. If it has no real solutions, means it has 0 x-intercepts, which means it never crosses the x-axis. Okay? However many real solutions tells you how many times it'll have an x-intercept. So if it said two solutions, two real solutions, I'd draw a parabola that went through there twice. So it's just a little bit of common sense, actually. The number of solutions tells you the number of times. The number of real solutions tells you the number of times it's going to cross the axis, and that's it. And then the stuff we've been doing for the past couple of days with our shading we were looking at. So I get to here, and I go, okay, graph this, remember to shade. Okay, get my vertex, opposite of B, over 2A. Okay, there's my X value. Again, I can get the Y plugging it into the calculator, or I can just go ahead, get this typed in the Y equals part, which I'm probably going to want to use in a minute here anyway. Bring up my chart, get my 2 in the middle, symmetry, yes. So my vertex is at 2, 8. Make my dot, oops, make my dot if I can see it, there we go. And then again, you might as well just use the calculator for the rest of your dots. Keep making dots, people, okay? Because that's going to help us on the shading part here in a minute. And I skipped one, yes I did. Ooh, now before I go connecting things, let me get the calculator out of the way. Is my connect the dots line to make my parabola going to be solid or dotted? And why is that? Solid because it's or equal to. Get my parabola rolling there. And again, to figure out where to shade, pick a test point. If 0, 0 is an option, that is my personal favorite, but any point in here will get you the same thing. So I'm going to test 0, 0. And again, f of x is just a fancy name for y. So when I'm plugging in, every time I see an x, I'm replacing it with 0. You kind of see why I like 0, 0. 0 reduces real easy. 0 plus 0 plus 4 is 0 greater than 4. Don't think so. If it's false, you shade in the area outside your parabola. If it's true, we shade inside. All right, last one. It's been a battle, but we're going to win. Okay, solve the inequality, write your answer in interval notation. You can do this via number line like we did it, or you can do it where you actually sketch it on here. I am more of a fan of doing it algebraically, just because if you don't get nice zeros, sometimes that can be a pain. Okay, I might even show you both. We'll see. So if I'm looking for zeros, I'm going to factor this. That may have just turned some of you off to this entire concept, but at least it's a diamond. Multiplies to a negative. So multiplies to 14. Numbers are 5 apart. 7 and 2. So my zeros, my intercepts, are at -2 and +7. Because remember, I'd set these equal to 0, and then I'd solve, which is going to change the signs on them. So what we do is we make ourselves a little number line. And we're going to section it off ABC. And here's how this works. We're going to test a number in section B. If it's true, the answer is there. If we test the section B and we're wrong, it's in the other two spots. So for instance, here I pick a number between -2 and 7. Gee, 0. How coincidental. So I'm going to test out 0. So, okay, 0 squared is 0. Minus 5 times 0 is 0. Minus 14 is less than or equal to 0. Is -14 less than or equal to 0? It certainly is. So my answer is right in here. And my interval notation is from -2 to to 7. We're like, well, what if I didn't do it that way? What if I wanted to use the calculator? Okay. If you wanted to go the calculator route, here's how it would look. I'd type it in. I'd go ahead, I'd do this. Now, here's my dilemma. You're like, uh-oh, he said dilemma. Well, here's my issue. My issue is my b value isn't a nice number. So it's going to take me a lot more time to be able to do it graphically, because now, as you can see, I don't see symmetry. And that makes it take longer. Now, I do notice, though, that my zeros are in nice places. Notice the 7 like I had there, and the -2 that I had. So that might make it worth it to you to deal with a -2.5 x value and graph that. And you could, but you won't need to. All right, we're running low on time. So again, you're looking at the test. And yeah, it's a chunker. I mean, we did a lot of talking, though, so it won't take this long for you, hopefully. But again, if there's stuff you haven't been doing, now you've gotten a review of every single thing in there. Go back, look at some of the homework problems, try them again. In an emergency situation, come and see me in the morning because, well, it's showtime.